Now in class 11th, I will discuss about the circular motion in the vertical plane. लेकिन vertical plane कौन से होते हैं? प्लेन दो तरह के होते हैं, हॉरिजेंटल, दिस इज नाउ हॉरिजेंटल, वर्टिकल लाइक दिस. Suppose we rotate the wheel parallel to the ground, then this is the motion in a horizontal plane. If this circular motion is given in the vertical plane like this is the vertical plane, and we rotate the object like this, then this is the motion, circular motion in the vertical plane. So let's this is the object is moving like this. This is the radius. R. This is now suppose the point A. This is now suppose point B. This is now suppose point C, and this is now suppose point D. This is now center. So this we take. Let here is the velocity VA. Velocity VA. Here the velocity is suppose this we name PQR is better is. This is now P. This is now your Q. This is now R. So this is now your VR. So this is, and the particle is tied with the string that it has the tension. This is now suppose tension T1. This is now suppose tension T2. This is now thread. Let a particle of mass m is rotated in a vertical plane. Whose radius R is the length of string. From which the particle is tied at one end and other end of string is at the center O. So now let's, at point P the velocity of the particle is Vp and at the point R the velocity is Vr, and we know that the velocity is given in the direction of the tangent drawn at the point of the circular path. This we know. And let this T1 and T2 are the tensions in the string at the point P and at the point R. So equation of motion. Equation of motion. What we have? Now since the weight will also act in this direction and here the weight will act like this. So now weight and so what we have? Now this weight instead of showing to like this, we will show it. This is now weight energy. So now what we have is T1 is greater than mg. So this T1 minus mg, this is equal to mvp square upon r. This is our centripetal force. This is our equation number 1. And in this direction what we have this T2 plus mg is equal to m vq square upon r, where vp the velocity at the point P and vq the velocity at point Q. So this gives the centripetal force. Resultant of these two gives the centripetal force like this one, because these two are in opposite direction and these two are in the same direction. So T2 plus mg equal to m vq square upon r. So you can see that if T2 is equal to 0, means the tension at this point P in the string is equal to 0, then what we have? mg equal to mvq square upon r. So this m and n will cancel. So what we have? This vq is equal to square root of rg. This is the minimum velocity for the body to move in the circular path. It is minimum velocity called critical velocity at point Q, at point R for the body in vertical plane. To move in the vertical plane. So VC, critical velocity, VC. VC equal to V square root of R. This is so much. Now the tension in the string at this point, this is we have taken to be 0. So we have to find that what must be the minimum velocity at the higher point, at the highest point, so that the particle could complete the circular motion. And you can see that the velocity of particle at lowest point P. Now this we using V square equal to U square plus 2AS. So what we have, this V is equal to VP. This is now your VP square equal to U square is so much at the point R. So this is now your RG square root of RG. This is so much plus 2 in place of A we write down G and S. This is equal to not 2R because this displacement is equal to 2R, the diameter of the circular path. So this VP square equal to RG plus 4RG. So what we have, BP equal to square root of 5RG. This so much is the speed at the lowest point. So this velocity is just square root of 5 times of this critical velocity. Or VB equal to square root of 5 into VC, square root of 5 VC, this critical velocity. This is so much. Then what is the tension at the lowest point? That is T1. Tension in string at lowest point P. This we are what we have is T1 minus mg is equal to m Vp square upon R. So this is now your m Vp is equal to square root of 5RG. Square root of 5R. This is not so much square upon R. So this is equal to your 5 mg. This is now your T1 minus mg. So what we have? T1 equal to 6 mg. So the tension at the lowest point is 6 times the weight of the body. So T1 equal to 6 into weight of particle. Weight of particle. So for the circular motion in the vertical plane, the minimum tension is 0 and maximum tension is that of your 5 mg. Minimum velocity is square root of rg and maximum velocity is square root of 5 rg. So for motion or circular motion in vertical plane, the minimum tension T minimum equal to T2 and this is equal to 0 and T maximum is equal to T1 and this is equal to your 6 mg. 6 mg. And the minimum velocity V minimum is equal to Vc equal to square root of Rg and V maximum is equal to square root of 5Rg. This must be so much. If this is not so, then there will be no circular motion. I will today and also will discuss about the energy of the particle. Energy of particle. And I told you that this is what we are having the circular path. This I have taken O, this is now your point P, velocity is Vp, this is your point Q, this is now point R, here the velocity is equal to Vr, and this is now point S. So here we are having the tension that I have told you. This is now your T1 and this is now your T2. So let us find the velocity at the lowest point and highest point and also at the point of Q and S. So at lowest point, P, what we have? The kinetic energy is equal to half m Vp square. So this is equal to half m Vp equal to square root of 5 Rg. This is now whole square. So this is now 1 by 2. So this is 5 by 2 Rg. This is now so much. mR. This is now kinetic energy. Then what about the potential energy? Potential energy. This is equal to m, g and h is 0 at this point P. So this is equal to 0. So potential energy is equal to 0. So what we have? The total energy is how much? Total energy. TE is equal to kinetic energy plus potential energy. So this is equal to your 5 by 2 mRg plus 0. So this is now your 5 by 2 mRg. This is equal to total energy T. This is so much. Now at the highest point, R, what we have? This kinetic energy is equal to half mVr square. So this is equal to half mVr, that we know is square root of Rg. This is now so much whole square. So this is 1 by 2 mRg. This is now kinetic energy. Then what about the potential energy? Potential energy. This is equal to mg. This is now 2r. Now from this to this is not 2r, the diameter. So this is equal to potential energy equal to 2 mRg. Now total energy is how much? Therefore total energy is equal to kinetic energy plus potential energy. So kinetic energy is how much? 1 by 2 mRg plus this is now 2 mRg. So this will be how much? Total energy. This is equal to 5 by 2 mRg. This is not so much. It means that total energy at the highest point and lowest point are the same. So it follows the law of conservation of this mechanical energy. And you can see that here the potential energy is 0 and here the potential energy is equal to 2 mRg. So this is now maximum mode. Potential energy increases when the particle goes from lowest point to the highest point. And the kinetic energy, this is now 1 by 2 mRg. Here this is now 5 by 2 mRg. So kinetic energy decreases. So this kinetic energy is 1/5 of this kinetic energy at the lowest point. So thus the total energy remains the constant. And if you want to find out at the point Q and S, you can also find in a similar way. At point Q. Now let us find here this at this point Q. What will happen this? The kinetic energy. This is equal to half m. This is now suppose now bq square. Bq. Let here this velocity is bq. This is now bq. Here this velocity is suppose bs. The particle is moving like this, anti-clockwise. This is moving anti-clockwise. So how to find this bq? Velocity at point Q. This VQ equal to square root of how much? This is now your 5Rg. Square root of 5Rg whole square plus this is now 2Gr. 2Gr. So this is how much? Minus 2Gr, because the particle is going up, so this is against the value of G. So what we have, this VQ is equal to, this will come out to be your square root of 3R. Therefore, the kinetic energy is equal to half m VQ square. So this is now half m VQ is equal to square root of 3R whole square. So this is now 3 by 2 mRg. Now what about the potential energy? Potential energy is equal to mg and r, the vertical height from lowest point to the center, that is parallel to this point Q. So this is mgr. So what we have? Potential energy equal to mgr. Therefore the total energy, total energy, this is equal to kinetic energy plus potential energy. So kinetic energy is equal to 3 by 2 mRg. This is now your mRg. So this is now again 5 by 2 mRg. This is now total energy. So at the point Q, the total energy is again equal to 5 by 2 mRg. Similarly, if you find the kinetic energy at the point S, point S, what we have? The velocity Vs equal to square root of, this is now you what this PQR, this is now your VR square plus this is your 2G, and now the radius R. So this is equal to square root of RG. This is so much square plus 2 RG. So this is equal to square root of 3 RG. This is now again equal to Vs. So what we have, the kinetic energy 1 by 2 m Vs square. So this is 1 by 2 m square root of 3 Rg whole square. So this gives you this kinetic energy equal to 3 by 2 m Rg. And now what about the potential energy? This is now mg. The displacement is equal to r, the radius. So this potential energy is equal to mRg. Now total energy is how much? Therefore total energy is equal to kinetic energy plus potential energy. So this is equal to your 3 by 2 mRg plus mRg, or this total energy is equal to 5 by 2 mRg. So thus we see that when the particle undergo a vertical circular motion, then in that case the total energy remains constant, though there is a change in kinetic energy and potential energy at different points, but the sum of the energies will remain the same. Hence, sum of kinetic energy conserved in vertical circular motion. So there is the conservation of energy. So this I told you that what will be the value of this tension at the lowest point and at the highest point, and then the energy at the different points. So as the particle moves from higher point to the lower point, then the velocity increases, so kinetic energy increases, but potential energy decreases, but the sum of these two is constant. When the particle goes from lower point to the higher point, the velocity of the particle decreases, so the kinetic energy decreases, but potential energy increases. The sum of these two energies is a constant. So it means that when the particle goes in the vertical circular motion, the energy, the sum of the kinetic energy and the potential energy remains the constant, though they change at every point. But even we are having that the sum of these two will remain constant. So this I have told you that a general discussion about the energy of the particle and the tension and the critical velocity. And in the next lecture I will tell you that how to find the velocity at any point at some angle theta when the particle is executing the circular motion in the vertical plane. So this is about the first one, and the second I will tell in the next lecture. Thank you very much.